Unit 6, Lesson 6, The Law of Sines. In this opening exercise, we are given triangle DEF, where angle D is 22 degrees, angle F is 91 degrees, DF is given as 16.55, and the length of EF is given as 6.74. Find DE to the nearest hundredth. Okay, so we're being asked to find this value here, but we've got a snafu. We can't answer this question. So why can't we use basic trig or Pythagorean theorem to find DE? Does anybody know? Look at the picture. We can only use basic trig or Pythagorean theorem on what type of figures? That's right. Right triangles only. We do not have a right triangle. As a result, we can use another formula. It's called the law of sines, and you could use this on any triangle, including right triangles. So this is what it looks like. You're going to use two of the three ratios, and it all depends on the information that's given, or you're going to have to look for some more information in order to fill in to find out what the ratio of the sides you're going to be using. So it's the length of side A over sine of A, it's the length of B over sine of B, or the length of C over sine C. And as you can see, smaller case A, B, and C are the values for the length of the sides. So let's take a look at example 1. We're going to try the opening exercise, again, using the law of sines because we can't use basic trig or Pythagorean's theorem because it's not a right triangle. The information is already filled in, and we want to find the length of DE to the nearest hundredth. So the length of DE, which is right here, is across from this angle F. So I'm going to use lowercase f as the variable. So even though we're not using sides A, B, and C, we can use sides D, E, and F. So across from angle D is side lowercase d, and across from angle E is side lowercase e. Now we can set up two ratios. I'm looking for side F, and that is across from the 91 degree angle, which is angle F, so sine of 91 degrees, and that's equal to, I have the length of D, 6.74, as well as the angle that's across from it, which is 22, so sine of 22. I'm using these two because I have them. I'm not using this side because I don't have this angle E. And all I have to do is cross multiply. But I'm not going to cross multiply all the way because some of the steps will be redundant. So since I'm solving for this lowercase f, all I'm going to do is multiply 6.74 to sine of 91 degrees, and I'm going to divide that all by sine of 22 degrees. So go ahead and plug that into your calculator as we speak. So the length of side F is 17.99 rounded to the hundredths place because that's where you're asked to round. As a result, the length of side DE is what is equal to 17.99. Any questions? Take this opportunity to pause and ask me at this time. Okay, exercise 1. In triangle ABC, the measure of angle A is 33 degrees, A is 12, and the measure of angle B is 43 degrees. What is the length of side B to the nearest hundredths? First thing you need to do is draw a picture. It's very hard to do these problems without drawing a picture. Label appropriately. So we have capitals letters A, B, and C for the angles. The measure of angle A is 33 degrees. Side A, lowercase a, is across from the 30-degree angle of A. The measure of angle B is 43 degrees. And we're asked what the length of side B is, so that's opposite angle B. So the ratio of sides is going to be side B over the sine of 43 is equal to sine of 33, and we're given the length that's opposite that is 12. B is equal to 12 sine 43 and cross multiplication divided by sine of 33. Plug that into your calculator and you're going to approximate to the nearest hundredth spot. If you got 15.03, that is perfect. Moving on to the next. In right triangle PQR, stop right there and draw a picture. Right triangle. Make sure you know what letter gets assigned to the right angle. As you can see, angle Q is 90. That means P and R are the other two acute angles. Angle P is 57 degrees. So I'm going to write that in there. And the length of the side, P, which is across from angle P, is 9.3. Find the measure of side Q. So that's across from the right angle, our variable in which we're looking to solve. So I have Q divided by sine of 90 is equal to 9.3. The length of the side, that is opposite angle P, which is sine 57. So Q is equal to the cross multiplication of 9.3 and sine of 90 all over sine of 57. Go ahead and plug that into your calculator and we'll round that to the nearest tenths place as specified. Bingo! You got it if you got 11.1. In triangle XYZ, go ahead and draw the picture, label. The measure of angle Y is 87. The side across from it is 14. And the side across from angle Z is 12. Find the measure of angle Z to the nearest tenths. I'm going to label that with theta. You can label it with X. That's entirely up to you. So it's 12 over sine of theta is equal to 14 over the sine of the degree angle of 87. We're going to cross multiply. So 12 sine of 87, and we are going to switch the 14 in sine of theta. You can go ahead and cross multiply them, but you're going to see that you're going to end up dividing out the 14, so it's just an extra step that we can eliminate, with your understanding, of course. So since we're looking for the angle measure, theta, you're going to have to use sine inverse using this ratio. So sine inverse, 12 sine 87, all divided by 14 is equal to theta. Go ahead and plug that into your calculator right now. Don't forget to round to the nearest tenth spot because that's where you're asked to round. Follow the instructions. Inevitably, hopefully you got the same thing as I did, 58.9 degrees. So now we have some applications to real world problems. So they're explaining the picture or diagram that's given. A fire breaks out only 80 feet from the ranger's tower. The tower needs to run the water tower to the open tower spout so that it will flood the area and put out the fire. How far is the run from the tower to the water tower to the nearest foot? So we're looking for the distance between ranger's tower and water tower. And we're given the value of 80 feet for this side, and we also have the angle measure that's across from it. In order to find the value of x in this problem, we are going to need the value of the angle that's across from it. And we can find that because we're given two angle measures, and we know that in a triangle the sum of three angles is equal to 180 degrees. So we can subtract the sum of 46 degrees and 28 degrees from 180, so that's a sum of 74. 180 subtract 74 is 106 degrees. We know what the angle measure is across from x. So we have x over the sine of 106 is equal to 80 over the sine of 28 degrees. So x is equal to 80 sine of 106, all divided by sine of 28. Go ahead and plug that into your calculator and tell me what the answer is to the nearest foot. That's right, 164 feet. And we need to restate this answer in the context of this problem since it is an application real-world problem. So the run is 164 feet from his tower or the ranger's tower to the water tower. Another application problem. There's going to be more steps in this problem compared to all the others, just to forewarn you. So there are two lighthouses that are 30 miles apart, as you can see in the diagram. On each side of shorelines run north and south as shown. Each lighthouse person spots a boat in the distance. One lighthouse notices that the location of the boat is 40 degrees east of south, and the other lighthouse marks the boat as 32 degrees west of south. What is the distance from the boat to each of the lighthouses at the time it was spotted? So we're going to be looking for X and also Y. And I see that I have a right angle here, so I know that the difference between 90 and 40 is going to give me 50. And I see another right angle here, so the difference of 32 and 90 is going to give me a difference of 58. So since I know that the two angle measures inside the triangle is 50 and 58, if I take that sum and subtract it from 180 degrees, because the sum of three angles in a triangle is 180, I can get the third angle measure, which is going to help me find the rest of these values here. So 50 and 58 give me a sum of 108. Subtract that from 180 and we get it 72 degrees. So I know the length of the side already that's across from it. That's 30 miles. So 30 over sine of 72. And I also have to use it again to find y. So I'm going to use it here in order to find x. I'm going to use it here in order to find y. So across from x, I have angle measure 58, so sine of 58 goes beneath x. And in using the law of sines below, I'm going to use angle measure 50. Okay, and then I'm solving for x, so the ratio is 30 sine 58 over sine of 72 is equal to x. And down below, I'm going to have 30 sine 50 all over sine of 72. Plug those two into your calculator, and we're going to solve for the values of the length of sides, which is ultimately the distance of the boat from each of the two towers. So 27 miles, because we're asked to round to the nearest mile, is the first value. And for the second value, y, it is 24 miles. And in the context of this question or problem, that makes sense, because opposite the smallest angle is the smallest side. And then we have the middle angle, which we have a middle value, 27. And then opposite the greatest angle is a length of 30 miles, which is the longest side. So it fits into the properties of triangles. This concludes the lesson, so you're responsible for the homework. The quicker you turn it in, the quicker you're going to get a grade.